So we have a cylinder of diameter of 70 millimeters with an axis length of 110, and this is completely penetrated by a cone. And this is completely penetrated by a cone of diameter of 80 millimeters and axis length of 120 horizontally. Now both axes intersect and bisect each other. We want to draw projections showing the curves of intersection. Okay, so I think what we can do or where we can start is we can draw in the front view of the cylinder that's standing on the HP, so that we can draw with a rectangle. Okay, so that rectangle then will have proportions. Let's look at so the diameter is 70 and the axis length is 110. Okay, so 70 by 110, that is that, and then we can have some center line that's going through, and then we can have the top view of that cylinder. So all right, now for the cone that's going through, we told that the cone has dimensions of it has a base diameter of 80 and an axis length of 120. So we can draw that in place. So we could just use a line. Okay, so I'll draw it outside, and then once I'm down, I'll position it where it needs to be. So this part here, according to the question, is 80. And then the vertical distance, let's draw that using, so this vertical distance we told is 120. Okay, so I have a line. So I'll select them and then move it by the midpoint, and then position it at the midpoint. So make sure you are making very good use of your snaps. So what I want is the midpoint, like that. And then is in the same vein, I can copy CO for copy. Then I want to copy by the midpoint once more, and then position another one at the midpoint of the circle, like that. This is the kind of problem that requires us to have only two views instead of three. So you take notice of that. And then I want to break at some point. So break at a point. I want to break this here. And then break at a point once more. I want to break this there. And then once again select this and break it there. And then select this and break it there. And then I'll do same here, then same there. So I'll go for this and then that, like so. Now what I want to do is I want to select these portions and they should be drawn in with hidden lines. Okay, so what I'm going to do next, so for a problem like this, in place of our usual third view, I would rather draw an arc or a semicircle to represent the projections coming from the side view. Okay, so let me go for perhaps this and then select this method. So that is my center. I want to start there and then end here and get a line and connect this to that. And then same, I want to connect this by this angle here. I want that to be 45, and of course the radius is 40, right? So like that. And then I do same on this side. So okay, so this represents the divisions I want. So I will just label them. Okay, so before I continue with the labeling, we ought to join. So line, and then we ought to join this to that, and same here. I'm going to copy all the tests. So the line is selected in addition, so I'll just go to quick select. And then object type, I just want to select just the M test, and okay, then copy those using this point, and then place them there. And what I want to do is, now mind you, from the top view to the front view, there is going to be some rotation of the view, so the numbering will also be adjusted accordingly. So this is going to be 1 prime, 2 prime, and then 3 prime. So that should be 4. Okay, so now that I have that, I'm going to draw connections from these points to the apex. So line, and then from this point to that point, and then there should be another one here. So from here all the way there, let's do same there. So I'll just perhaps just copy these as well. So CO for copy, then I can copy them maybe by this midpoint, then paste them there. Okay, so now we ready to get our curve of intersection. So let's go for maybe the yellow construction line, and then once I have line, let's do perhaps 1, 2, and 3. So that is 1. This is where they meet. So 1 and the top view of the cylinder meet here. So I'll project that point to 1, and that's 1 here is obviously on the center line. So that is my first point. So let me do PO and then put my first point there. And then I'll go for 2. So line once again, and then 2 meets at this point, and 2 should be, 2, 4. So this is where I want it to be. Go for PO, and then PO, and then I can go for 3 here. So line, and then 3, 4, 3. That will be this point. So PO once again, and then that is this point. If I were to do same on the other side, I would have, let's say, line. So 1 on the other side. So 1 goes through, and then 1 here is going to be around this point. Okay, so PO, and that is 1. Then I can go for 2. So line, so 2 is going to be this point, truly very close. So 2 will be around here somewhere. So PU, that is 2, and then 3 is going to be around here, so line, and then 3 should be somewhere there, so PU, then that is 3. Okay, so obviously I can select 1, 2, and 3, and then select these as well, 1, 2, and 3, then go for mirror and mirror them like so. All right, and then finally I can go for the arc to connect them, but I'll use obviously a spline. So if I were to zoom in, I'm going through this point, that point, this point here, and finally there. Right, so I'll be getting something like that. Okay, and then I can spline once more, and then I have, that was 3, that is 2, that is 1, and then on this side I have say 6 or 6, and then 7. Okay, now I can trim the unwanted parts, so TR for trim, and then let me use cutting edges. So this and that are cutting edges, and then I'll cut that, and then same thing, so trim again. Cutting edges are this and that, and then I'll cut this. Okay, so this basically would be the solution required of us